Hello everyone, welcome back to Hydrology Hub. In this lecture, we will continue our journey with HEC RAS, focusing on some very important components of geometric data, that is storage area, 2D flow area, SA2D connection, and boundary conditions. These elements are essential when we start representing floodplains, reservoirs, lakes, wetlands, and urban areas in realistic way. By the end of this video, you will be clearly understanding what a storage area is and when to use it, how to create a 2D flow area, how SA2D connection works, and the boundary conditions. So now, what is geometric data in HEC RAS? In HEC RAS, geometric data defines the physical layout of the system we want to model. This includes river center lines and the cross sections for 1D flow, storage areas such as lakes or floodplains, 2D flow areas for spatially distributed flows, and hydraulic connections between these elements. Now, first of all, we'll see storage area. A storage area in HEC RAS represents a region where water can accumulate and be stored, but flow direction is not explicitly computed within the area. Typical example includes reservoir behind dams, natural lakes, wetlands, floodplain depressions, and detention basins. In a storage area, HEC RAS uses a stage storage relationship, not velocity based routing. So, first of all, we will open the HEC RAS. Once you have opened the HEC RAS, go to the file, create a new project. So, we are creating a new project. After that, you see the whether your unit system is correct or not. Check the unit system. So we will have the metric unit system here. The unit system is a SI unit system. Now next, we have opened the RAS mapper. In the RAS mapper, again go to the terrain and add the terrain, import that one here. So first of all, we will incorporate the coordinate system. So the projection file we have imported here, and after setting the projection file, we will upload the dam. So now the dam is added here. It is processing the dam. So once the dam will be processed, it will be shown on the RAS mapper. So now the dam has come close here. So here is your dam. Now the next step is we will add the map, background map, Google map over here. So that we can identify where is our dam and where is the river. This will help us to delineate the reservoir area and the flow 2D areas downstream the dam. So in the map, you can see in the Google map, it is very much clearly visible the where is your storage area, reservoir storage area is there. So now we'll just place the your dam and the map layer in such a way. We'll just change the transparency so that it can be clearly visible both the maps. Okay, dam and this thing. Now we'll add the new geometry. So we are adding the new geometry. So new geometry is being added here. In this new geometry, we will start creating the geometries. Okay, for that we have to first edit the geometry. Click on the edit geometry. Now here you can see different options are available. So one by one we can go and add the different components of the geometry. Okay, so these are the tools are there for adding the geometry. So first of all, we'll go to the storage. So always use the left mouse for button for all making these boundaries. So we'll go to the storage, okay, area. So the storage area will mark the reservoir storage area. As I mentioned that from the Google map, it was very easy to see where is the reservoir area is there. So accordingly, you can just mark the reservoir storage areas. Okay, so this geometry we are marking. So use the left mouse button to click on the on different points and then double click over there and your geometry will be final. Okay, give the name, proper name for the geometry and say okay. Now your reservoir storage area has been created. So this is the storage area. Now we can zoom the map, see up to which point we have to make the 2D flow areas. Okay, just we'll move the map so that the complete area can be seen on the map. Now we will go to the flow 2D areas and select the parameter here. And then once we select the parameter, we'll start again marking the 2D flow area. Similarly, as we have marked the storage area using the left mouse button, we are putting all those points and then double click on that one. Then it will ask the name of the 2D flow area. Give a proper name for the 2D flow area. And then after that, you can click OK. Now it will ask about the creation of the mesh. You can give the size of the mesh. So here we are giving 30 meter by 30 meter. You can generate the mesh here. So the option is you can generate the mesh here as well as after exporting or taking this data to the geometric file. There also you can create the as we have seen in the our earlier videos or so your 2D flow areas are created. Now for creating the 2D SA2D connection, you just click on the SA2D and then mark a line in between the 2D flow area and the storage area so that the 2D flow connection can be created. Then shape, store it, give a proper name and save it. Define connection type, weir, gate, culvert or breach, crust elevation, weir coefficient, breach parameters if applicable. This is extremely important in dam break analysis, plain overflow studies, reservoir routing, urban flood pathways. An SA2D connection defines how water moves between storage area and the storage area and between storage area and 2D flow areas, between 2D flow area and 1D river. These connections can represent embankments, weirs, spillways, roads, levees, natural high ground. Similarly, you can create the boundary condition, downstream boundary condition, create a downstream boundary condition, select the downstream boundary condition, BC line, and create a line at the downstream side, and then give a proper name to this boundary condition and save it. So your 2D boundary condition is also created. Boundary conditions define how water enters and leaves the model domain. Without correct boundary conditions, the model may not run or results will be physically meaningless. Now, the types of boundary conditions are upstream boundary condition, that is the flow hydrograph, storage hydrograph, downstream boundary, normal depth, rating curve, fixed stage, and the time varying stage. Now, one by one, you can export all these files, means the storage areas, 2D connections, 2D flow area, and the boundary condition. in the form of the shapefile, and you can store in your PC or in your laptop. Okay, and whenever you are using or developing a model in future or giving these data to some other person, you can just develop and import these shapefiles to the model. Okay. Now, the common mistakes and practical tips. Some common mistakes to avoid: using storage area instead of 2D flow area for floodplain mapping, very coarse mesh in urban areas, incorrect crust elevation in SA2D connections, and the wrong downstream boundary condition selections. Now, to summarize, storage area are best for simple water level variation. 2D flow area are essential for realistic flood modeling. SA2D connections control flow exchange, and the boundary conditions define the driving force for the model. Well defined geometry is the heart of any successful HEC RAS model. If you found this lecture useful, like the video, subscribe to Hydrology Hub, leave your questions in the comments. Thank you for watching.